In this video I will show 3 exploitation challenges from the Internetwache CTF, which happened already a while back, but I didn't get around editing it, so here is it now. The first level is Exploitation 50, Ruby's count. Hi, my name is Ruby, I like converting characters in ASCII values and then calculating the sum. And we have here a server given with an IP in it. It wants us to provide some ASCII values of 10 characters. We didn't enter enough, and you see also matching only A to F. So when we type in 10 A's, we get the sum of 970. Now let's type in the sum of 10 F's, that's 1020. But that's not enough. We need to get higher than 1020. But how can we get a higher sum if we are only allowed to use maximum of 10 F's? Well, there's a weirdness to Ruby regular expressions which you have to be very careful with. And this is what we are going to exploit here. So if we use debugX to look at the regular expression, we can see that it looks for the start of a string, then 10 times the characters A until F. But by default, Ruby's regular expression match multilines. So as you can see here, a line with the F's and then a new line with ASD afterwards still matches. So the idea is clear. We want to just inject 2 lines into the whatever we are sending to the server, and we can do this with using echo. But when I use echo and the FFFs, I somehow don't see the result that I expect to send back from the server. And I don't understand why. So now I get really frustrated and play around with it and get confused why whatever I'm sending, I never see the result. You can see me here angrily just sending the same command over and over again. Well, I play around with sleeps and whatever, just like to see if I can wait for the response. But then I was thinking similarly to with exploit to leave the input kind of open. I use cat and that seems to do the trick. Now I'm able to get the response properly back from the server. And yes, we get the flag. Ruby regex fail. The next challenge is the Exploitation 70, flag store. Here's the ultimate flag store and retrieve the flag whenever you want. We have a zip and again a service given with IP and port. Let's have a look at this server. So we take the IP and the port and connect to it with netcat. Welcome to the flag store, choose an action, register, login, get flag, store flag. Okay, so we don't type in the word, but the number. Please log in first. So let's have a look at this in the source code. So in main, we see here an endless while loop where it says choose an action, prints the menu followed by a huge switch case statement depending on which value you choose. And to do something, we first have to log in. But if we look at the get flag option, we also see that there's a case in where it checks if you are admin, is admin. So we have to log in first, but there was a menu for registration, so logging in might be easy, but there's this another variable, is admin, so somehow we have to be admin to, as you can see here, print the flag. For the login, you use a username and password, and when we look at the variable definitions, we see that the username is 500 bytes long, then afterwards come the is admin flag, and after that the password. And if we look in the case for the login, we see that here's a safe scanf that only reads up to 499 characters, so that seems to be safe. But the other case, the registration, seems to use scanf and not have a set length. So the idea is to register an account with a super long username, which might overflow into the is admin flag. So we use Python to just generate a super long string, and then we select registration and enter a password, but the password was too short, so select a longer one. And we registered now an account. Now the admin flag should be set, and if we have a valid login, we should be admin. So we have to specify username, ASD, but those are the wrong credentials, obviously. So we register another account that has a shorter username. We log into that one, but with the registration, we have already overwritten the admin flag. And if we now select the menu item get flag, we get the flag. Why has flag. Okay, we solved those 2 challenges pretty fast. So now we move on to the last exploitation challenge, exp80, which requires a little bit of more time, but is super fun too. So remote printer. Printer are very important for Office, especially for remote printing. and there is again a zip file available that we can download, and a service, an IP, and a port. So let's first connect to this service and see what is happening. This is a remote printer. Enter an IPv4 address. We enter an address and a port. Thank you, I'm trying to print this address now. Okay. So it has something to do with an address and a port, so we might need a server with an IP that is reachable from the service. Also, we should start analyzing this file, so we open it in Hopper. So let's first look for strings. This is a remote printer. That is the first string printed, so we can quickly find the main menu. And you see here, so this is probably the main function where it asks you to enter an IPv4 address and a port by using scanf. After you have entered those addresses, it tells you that it's trying to connect there and calls this other function here. And you see here already that it like opens a socket and creates the struct for the connection, and then tries to receive some data from it and call printf. And this printf looks already pretty bad. If you have seen my format string exploit vulnerabilities, you may remember that if you are able to control the format part, the first parameter of printf, then it's pretty bad. There's another interesting string saying yay flag that is probably printing then the successfully flag. And if you look at the function where this is from, it tries to open a file with fopen, and that points to another string which is not properly analyzed here. So it tries to read the flag.txt and then print this content of this file after it opened it. So this is obviously the function we want to call, because this will then print the flag. Okay, we know now that this tries to connect to an IP and port you specify, receive some data and printf that, which obviously leads to a format string exploit. So we need a public IP address to test this. I'm using DigitalOcean to quickly spin up a server just for an hour or so during the CTF, which I can then later throw away and only pay this 1 hour. And this way I can get a public IP to play with, and it's a Linux machine, so it's great. So it takes a little bit to set up, just a few seconds or a minute maybe, and then you are able to connect to it via SSH, and then we can test it. Cool, done. Let's copy the IP and use SSH to connect to this new server. Okay, cool. We are on the server. Now we listen on one port 8080 and we pipe in ASD into it. So if something connects to this IP now on port 8080, it should print it. So let's connect to the servers. We type in our IP and our port, and we can see that it prints the ASD. And we think that it might be a format string exploit. So let's play around with this. Let's use Python inline to print a lot of %p or %x or whatever you want, to see if we can in fact control the format specifier, and we should be able to leak addresses or generally values from the stack. So Python -c and then print and then the percentage stuff. Okay, now we are listening. Now let's connect again to the print server. We enter our IP and port. Yep, we see here all these weird characters. Now let's prepend a few recognizable characters to our string, maybe just like some A's. And then let's do the same thing again. But I don't want to type in the IP and port all the time, so I write this in a file and then pipe that into it. But again, I kind of fail again. If I just do cat, it doesn't work, so I have to like concatenate two cats, so I leave the input open and don't close it. At least that's what I guess is the reason. If I'm wrong here and you know it better, please do tell me. And if we scroll to the start, yep, there are our for 1 for 1 for 1 for 1. Those are our 4 A's. So now we know the offset of our string on the stack. This means we can place there an address where we want to write to and use %n to write to it. If you don't know how format string exploits work, check out my introduction to hacking videos about format string exploits. So first of all, let's get a few important addresses. For example, one of the important addresses is the address of the goal function that we want to call. That is the getFlag function, and this has the address 8867. Now, if we wanna like overwrite, for example, the global offset table of a certain function, we have to figure out what function is called after the printf so we can smash the table. So let's go back into the function that is reading our string and printing it. And we can also, rename it to have it better documented. And after the printf, there is a call to close. So we can now go to the close call, which is the global offset table. I've also made recently a video about that one. And if we write to this address here, the global offset table entry address, we can specify and redirect the code execution to whatever we write there. So our goal is to write the address of get flag at this location. So now let's modify and enhance our exploit proof of concept here a little bit further. First of all, let's import struct so we can convert between integer numbers and binary strings, because we want to write down the address to reference it from the stack with %n. And then we also replace the 500 piece with something that is more reasonable. We can count how far away the AAAA is, because this is where we want to put instead the address. And we can simply count how many values are there before we hit the A's. So there are 6 values before, and the A's are the 7th values. So we simply want to use 6 different percentage X's to print stuff. And then the 7th one hits our address. So we can do, for example, 6 percentage P's, and then at the end the percentage N to reference that. But instead of the A's, we obviously want to place there the address. So we can already place here the address and see if that works. Now I opened this binary in GDB and had set a breakpoint before. And now I'm using the exact same address, obviously with my own binary here, to connect to my server and get the format string back. And we can see that we hit now the breakpoint. And now we want to look at the global offset table. So the breakpoint was after the printf, and we want to check if we successfully have overwritten the global offset table entry. And we did, so it's 32 instead of a huge number, because we printed already 32 characters. Now we can calculate how many characters we need to write to get the address. We do this in 2 writes, like my other format string video. So first the lower 2 bytes, and obviously we also have to subtract again how many characters we printed. That's 32. And then we can simply enter the decimal version of that number before we perform the print, the percentage n. That should write at least the 2 lower bytes successfully in the global offset table, and we are one step closer. So we execute again our exploit code. We are listening now, and we connect to it with our binary, and again check if we have successfully overwritten the amount of characters. We run again, and we look at the global offset table entry, and yes, we have the 8867 in there. So now we simply need a second write for that one. So we first take the address that we have first written to, which we have to write at +2, but we also need 4 more bytes in between before we place this address, because to get the other write working, we consume 1 more element to pad it, and after that the percentage n. So we always have this pair of percentage something and percentage n with the padding for a write. So that's why we have to make sure we consume 2 bytes in the address. And so if we do this, we get now 887b there, and that is obviously a little bit too high, but we can use this trick that I showed you in this other video, basically write up to 3 bytes, which will overflow, but it doesn't matter for the global offset table. And we can calculate again how much the padding should be to be able to write the correct value. And I'm converting again hex values to decimal with Python, and we place it in there, and then we can test it against the binary. I run it and throw it against the binary, but it doesn't work. The address seems to be weird, and I didn't realize that because I extended now the characters with the B's and the new address, that I also shift around how many characters are printed for the lower bytes, and it's just not working, and I'm constantly screwing up how many characters I'm printing, and it's not, and I can't hit it anymore. So it takes for me a while to realize that what my mistake was, and when I I noticed it when I wrote my goal and where I am right now under it, and realized, oops, my lower bytes are higher. I accidentally added more bytes and my calculations are completely screwed up. So I have to calculate again, compensate for those errors, and eventually I figure out how many characters I have to print to write the correct address. Almost done compensating for a few more values here. And if we try it out now, we run it, we check. Again, basically now I'm back at the beginning. Compensate again back here for the second write. I run it, I check it, 08048867. That looks perfect. Great, so now it seems to work. That was annoying because I made mistakes and was not careful with what I'm changing. So now we should be able to run this against the real servers and overwrite the global offset table entry for close with the flag function and then execute that one to read the flag. Let's try it. IVO formatted remote printer. Awesome. We got that flag as well. Now I'm finally done with all my videos about the Internetwache CTF. We can look again at the tasks that I solved. I solved 3 web, 3 crypto, and 3 exploitation challenges. And we can look at the scoreboard, how I did. I think this was recorded just shortly before the CTF was over, I think. So I got place 254 with 610 points. And thanks so much at Internetwache for creating such a smooth CTF experience. It was a lot of fun and there were some great challenges that I really enjoyed working on.